All right, welcome back everyone to this little short series of videos in which I'm going to be going through a few exercises from chapter 6 to help you prepare for the term ahead. This first video is going to be on the unit circle, which is going to be super important going forward and understanding trigonometry. The unit circle is just a circle with a radius of 1, that's why it's called the unit circle, with the origin at the coordinates 0, 0. You can see that because the coordinates of the origin, so the coordinates of the center of the circle are at the origin, the outside of this circle is going to intersect with the x and y axes at the coordinates listed here. So 1, 0, 0, 1, negative 1, 0, and 0, negative 1. We're going to be using this circle to define something known as a radian. So up until now, you are well and truly familiar with the concept of degrees. Basically, we would say one rotation around the circle is equal to 360 degrees. This is this angle that we're using in maths since primary school. 360 degrees, it's a number that was chosen because there are roughly 360 days in the year, and it's just been rounded to 360 because that's a very useful number for division. It just has a lot of factors, so it's quite convenient. So that's the number that you're used to at this point. We're going to be using the unit circle to define something known as a radian, and the way that radians are going to be defined is that it is the angle when you travel a distance around the outside of a circle of 1 unit. So the distance from this coordinate 1, 0 to that point there. If that distance is 1 unit, then the angle that is subtended by those two vertices is going to be defined as 1 radian. And that symbol there is like a little C symbol. So it's like a half degree symbol. 1 radian is defined as being that distance right there. So we can see that there is this one-to-one correspondence between the distance around the outside of the circle and the radian. And what we need to remember from our earlier years of school is that the circumference of a circle, that is the total perimeter or the distance around the circle, is equal to 2 times pi times radius. And of course, the radius of a circle, or of this particular circle, is 1 because it's the unit circle. So therefore, the circumference of the circle is going to be equal to 2 times pi times 1, which is just equal to 2 times pi. Now, because there is this one-to-one correspondence between distance around the outside of a circle and radians, we can therefore say that, well, if the distance around the outside of the circle is 2 pi, then the total, angle of one revolution is going to be equal to 2 pi radians, which is to say that 360 degrees is the same as 2 pi radians. And this is a really useful fact that we can then use in various applications going forward, which we'll get to. Right now, we're just going to be focusing on how we convert between degrees and radians. So basically, you're going to start with this formula here, and I'm going to show you, you should be able to do this for yourself, how you can derive the formula that you're going to be using. So, for example, if we were to start with this formula here, and if we were to divide both sides by 360, for example, what we will find is that 1 degree is equal to 2 pi radians over 360 degrees. And because 2 goes into 360 180 times, we can simplify this down to pi radians over 180 is equal to 1 degree, right? So if we know that 1 degree is equal to pi radians over 180, we can then use that for our conversions. So for example, if we're trying to convert from from degrees to radians, we can go ahead and multiply it by this number here, this pi over 180 ratio. If we do that, so if we multiply by pi radians over 180 degrees, what you're going to notice is that the units are going to cancel out. So we have the 30, we have that degrees cancels out this degrees because we're dividing by degrees. and that leaves us with 30 times pi over 180, which is just the same as 30 pi over 180, and 30 goes into 180 6 times, so therefore this is equal to pi over 6 radians. Okay, now moving on to this next one here, if we want to convert 50 degrees into radians, we can just do the exact same thing. So we multiply by pi radians over 180 degrees. Once again, the exact same thing happens first. The degrees cancel out, and we're going to get a unit of radians in our answer. And then we can just do 50 pi over 180. Well, what are the common factors here? We can see that both 50 and 180 are both divisible by 10 because they both end in a 0. So we can, I guess, divide both those numbers by 10, which means the zeros cancel out, and that leaves us with an answer of 5 pi over 18 radians, which is our fully simplified result because 5 and 18 do not have any common factors. If you had access to a CAS calculator, of course, you could just type this into the CAS calculator. So if I want to convert 115 into radians, I would once again multiply by pi radians over 180 degrees. So let's do that over here. So we can multiply by, use this button here to get your fraction symbol, pi over 180, hit enter. It's roughly equal to 2.001. So 2.001 or 7? 7, yeah. All right, and I guess one little realization that you can make here is that given that we're talking about, 360 degrees is equal to 2 pi radians, we should see that 300, like if we were to multiply by this 360, we would get 2 pi. All of these numbers, if the angle is less than 360, all of these numbers here that we get as our answers should be less than 2 pi. So it makes sense that a number that's somewhere between 90 degrees and 180 degrees is somewhere between half of pi and pi. So that's just something to sort of keep in mind, if that helps. Now, if we wanted to convert from radian to degree measure, we're going to be multiplying by the opposite ratio. So we've got this ratio of, over here, we've got that 1 degree is equal to pi radians over 180 degrees. If we were to do the exact same thing and divide by 2 pi, we would find that 1 radian would be equal to 180 degrees divided by pi. So if we want to convert from radians into degrees, we need to multiply by this ratio. So again, let's set that up. So it's going to be multiplied by 180 degrees over pi radians. It's always just good to double check if this makes sense. The way I like to think about it is if I'm converting from radians to degrees, I shouldn't have any pi's in the answer. So how do I get rid of that pi in pi on 4? Well, I divide by pi. So I'm going to divide this by pi, which means the pi is down the bottom of the fraction. So it's going to be 180 degrees over pi, not pi over 180 degrees. That might help you, I'm not sure. So first up, the pi's will cancel out, and then we're going to be left with 180 degrees divided by 4. And 180 divided by 4, well, that's 90 divided by 2, which is 45 degrees. All right, let's do the same thing with the next one. So we want to multiply 4 pi on 3 radians by 180 degrees over pi radians. So again, the radians cancel out, the pi's cancel out, and we're left with 4 times 180 over 3. It's 180 over 3. Okay, now 180 divided by 3, what is that equal to? That's going to be 60 degrees, and this is going to be 60 times 4. So 4 times 60. Now 60 times 2 is 120, so this is going to be 240 degrees. Okay, that was a little bit of a trickier example. Again, if you have access to a CAS calculator, you can just type this in. So for this one here, we want to multiply by 180 over pi radians, and we're converting from degrees into radians. So we just open up CAS, we go 0.8 times 180 over pi, like that. And we can see that's roughly equal to 45.8. So remember, this is an approximately equal to. So approximately equal to 45.8 degrees. All right, so that's how we use the unit circle, and that's also how we convert to degrees and to radians. All right, I'll catch you guys in the next one.